Hi guys, it's Miss Griffin. We're taking a look at Unit 4, Skill 3, Part A. Sorry that we're splitting the skill up into 3 parts again, but I think it's necessary because we need to build up to that third part, Part C. We're going to be taking a look at proofs. We haven't done proofs so far in this course, and they're going to be using a lot of definitions and vocab words, some of which you already know, some of which you're going to learn in Part B. And so it's important that you get to start memorizing some of these vocab words and definitions, like making flashcards or using Quizlet on a computer to make virtual flashcards, anything that you can do for yourself to help you start memorizing some of these words and definitions. So our essential question, if you want to pause the video, says, what are we always allowed to mark or state without a given statement? And how many parts are needed to prove triangles congruent? Hopefully you can already answer that last part of the question, how many parts are needed to prove triangles congruent, because you learned in Skill 2 that you have 5 ways to prove triangles congruent, and in 4 out of the 5 ways you need 3 parts, right? S's and A's to prove triangles congruent. But we're going to get more information about that in this video. So our first proof doesn't have a given statement. However, it does tell us to prove that angle BCA is congruent to angle ECD. So if you find those angles and just kind of outline them, BCA is here and ECD is here. Our goal is to prove that those two angles that I just outlined are congruent. Hopefully you're recognizing immediately that they are already congruent because you see that little bow tie happening. But remember, a bow tie is not sufficient to say that those are congruent. You have to think back to their actual name over here on the left, vertical angles. You always look for an X to find the congruent vertical angles. So our first statement here is just going to be that angle BCA is congruent to angle ECD. Now typically we number the proofs, or number our steps in proofs, and we'll get to that part in a minute, but the first two here, where we're just talking about some definitions, are a little bit different. So we know that these two angles are congruent because a statement that you've been using for the last, month, vertical angles are congruent. Just like you were using when you explained why some angles in your picture were the same back in Unit 2. That's it. That's all we did. All we need to do. So we're moving on to something called the reflexive property. It says prove AD, the segment, is congruent to AD, the segment. If you look at this picture here, over off to the right, we have triangle ABD on the left and triangle ADC on the right. If I were to separate those two triangles, you can just watch here, separate them. I have A, B, D, and A, D, C. We notice that AD is a segment in both of the triangles, because if I separate them, AD is on both. So it says over here off to the left, look for a side or an angle that is shared between both triangles. So we can prove that AD is congruent to itself by something called the reflexive property. Notice that we've been using this T-chart, this statements and reasons T-chart. The statement is what you want to say about the picture or about the proof, and the reason is, well, your because. Instead of saying because reflexive property or because vertical angles are congruent, we're using this T-chart. So again, reflexive property allows you to say something is congruent to itself. Maybe we want to jot that down off to the side. Say something is congruent to itself. You can kind of think about it in terms of real life with looking at yourself in a mirror. When you look in a mirror, you see your reflection, you see your exact self. So here, reflexive property allows AD to see its exact self. AD is congruent to AD. Alright, so we're going to use those two things, the vertical angles and reflexive property, in proofs to help us prove that triangles are congruent. And remember that we have 5 ways to prove triangles congruent, so let's jot them down off to the side. Triangles are congruent by, pause the video, see if you can write them down, and then check back in with me. Okay, so I've got my 5 listed. Let's see if you got the same ones. I have side, 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 SSS. side, angle, side, SAS, AAS, ASA, and HL, but remember that HL can only be used with right triangles, so jot that note down if you didn't already. So we've got our first actual proof here. This is really exciting. Proofs are just like the best because you get to kind of argue a statement here and prove that you are correct versus a different person. So here it says given ML is congruent to PO and angle MLO is congruent to angle PON. So the first thing we're going to do is write down the given statement in our statements column. ML is congruent to PO. You literally just copy the entire thing. Angle MLO is congruent to angle PON. Notice that I numbered this time. I have first statement is number 1, so my first reason gets a number 1 as well. And the reason here is just given. Your first statement always comes from the given. So on the picture, we have to mark up what they tell us. We have ML congruent to PO, so find segment ML, put a hash mark, and PO, put a hash mark. And then put a check mark saying, yeah, I definitely use this. I already marked it up. Cool. Then I have angle MLO. Remember, we focus on the middle letter, so angle L is congruent to angle O. So find those two angles, mark them up, and put a check mark saying, yep, totally used it. So far, by looking at our picture, we see that we have a pair of sides congruent and a pair of angles congruent. But if we look back at our options for proving triangles congruent, it seems as though we have to have 3 pieces of information, right? Like 3 sets of sides, or 2 sets of sides and a pair of angles. 3 pieces of congruent corresponding parts. So we gotta try to figure out something else in this picture that we can mark up. Hopefully you're seeing the X that's being formed here. This X gives us some congruent angles that we talked about at the beginning of this section. Remember that you can always mark up vertical angles. It's always allowed. Some things you can't mark up, like you can't mark perpendicular lines being right angles unless they tell you that you have perpendicular lines. But vertical angles are things you can always mark. All right, so now we know that those 2 angles must be congruent, so remember how we used to have to explain every step when trying to find angles with actual numbers? Well, now we have to explain every step with the angles or sides that we're marking congruent. So we have angle LNM, that was this first one here, LNM is congruent to angle, now we're going to name it the other way, L, remember, matches with O because we marked those congruent. So if I started with L to N to M, I'm going to start with O to N to P. So O, N, P. Again, trying to match those corresponding parts up. And our reason here is not bow tie angles. Remember, that doesn't work. But our reason is because vertical angles are congruent. So we used both parts of the given, we used what we could find in the picture, and now I'm just going to go back and mark up my picture with S's and A's again to make sure I have everything that I need. So I have an S here still, I have an A here still, and now I just marked another pair of A's, angles. So now it looks like we have 3 pieces of information. We have an S, an A, and an A. So if I look at my options, I know I'm not going to use SSS, gone. Not going to use SAS, gone, because I have 2 A's and 1 S. So now I have to decide between these two. Is it AAS or ASA? Pause the video, take a second to think about it, and then hit play to hear the response. So notice here in AAS, the side is only touching 1 A. The S is only touching 1 A, so side is only touching 1 angle. If I look at my side here, it's only touching 1 of my angles. So I think that my triangles are congruent by AAS. And that's the reason to the proof statement. Triangle LMN is congruent to the triangle OPN. Again, this last statement was the proof from the original question. And the first statement was the given. First statement is always given, last statement is always the proof. And again, we prove the triangle's congruent by one of those 5 theorems. flip it over, we'll take a little bit more time to practice with these proofs because I know they're a little goofy. But always remember to number your statements and your reasons so that they match. Mark up your diagram with everything that you possibly can, and look for either vertical angles or reflexive always. Alright, so here our T-chart is drawn for us. I want you to pause the video, write in your first statement and first reason, because remember, it always comes from the given. That's an easy little bit to remember. So you're copying down the given right here in number 1. Okay, so hopefully you copied it down, word for word, and then your first reason is given, because they gave it to you. So now we have to go through, mark up our picture, and then check off what we've used. So angle PSQ, so we're looking at S, because it's in the middle, and PRQ, focusing on R, and marking them congruent, and then checking it off. Then the next one says SPQ, so S to P to Q, that's up here, 2 arc marks this time to show that it's different. And RPQ, that's the other side, and check mark to show that I've done it. So we're looking at our picture, we're trying to figure out, do we have enough information to prove what they want us to prove? Prove that the triangles are congruent, triangle SPQ and RPQ. So remember, to prove triangles congruent, we have 5 options. Those 5 options have S's and A's or an HL if it's a right triangle, but these are clearly not right triangles. So I'm going to look, I have an A and I have another A. And so the last thing I need is an S because there's no AAA. Remember, AAA is not okay. So look for a pair of sides that we might be able to mark congruent. Maybe something that's shared between the 2 triangles. If you were to separate the 2 triangles, what segment, what side length would be the same in both? Hopefully you're recognizing that this side length, PQ, if you separate the triangles, would become part of this triangle on the left and part of this triangle on the right because it's entirely shared between the 2. So that means we get to say that it's congruent to itself because it would be the same in both triangles. PQ is congruent to PQ. This is not because vertical angles are congruent. It's not even an angle at all. So remember that if you see yourself in a mirror, you see your same exact self, you see your reflection, so this is called reflexive property. Alright, so that's cool. Now we got a set of sides that I can mark with an S, so now it looks like we have another way to prove these triangles congruent. Step 3, the triangles are congruent, so SPQ, again this is coming right from the prove statement, is congruent to triangle RPQ, and then this is my because. The triangles are congruent because. And so if I look here, I've got 2 A's and an S, so it's either ASA or it's AAS, but it's only one of the 2 we have to decide again. My segment, my side, is touching just one angle. It's not touching the angle S over here, right? It's way away from it, not even touching it at all. It's not adjacent to it. So I have an S touching one A. So that, again, leads us to the conclusion that it's AAS. Alright, hopefully you're doing okay. All we're doing is taking the given, writing it down first. The second step is to find something else in the picture that we can mark up, because we've already marked the given, we check it off once we do. So that would either be reflexive, a shared side or shared angle, and or vertical angles, that bow tie that you can see made out of an X. And then we are able to prove the triangle's congruent, because we have 3 corresponding congruent parts. Alright, go ahead, pause the video, start your first statement, first reason for the next proof, number 3, last one. Alright, so you paused the video, you wrote down your givens, and now we gotta mark them up on this crazy looking picture. It says angle GHJ, so find the angle G to H to J, so focusing on H, put an arc mark. And find the other angle, GIK, so it's over here, put an arc mark and check it off to show that you've already marked it on your picture. And then GH is congruent to GI. Notice what I do to mark that whole entire side congruent. I put a big curly bracket and then I put a hash mark in it. And GI, big curly bracket, hash mark. The reason I can't just put a hash mark here on the segment itself is because K or J get in the way. So if they get in the way, make a big curly bracket and put a hash mark. Big curly bracket, hash mark. Now our goal is to prove that triangle GHJ, and I'm just going to outline this in orange real quick. GHJ is congruent to the other triangle that I'm going to outline in green, GIK. Now it looks to me like they're overlapping, right? You see the orange and the green that cross over each other in this general area. So I think that it would probably be easier to separate and redraw the triangles. If you have overlapping triangles, always just separate them. So draw the first triangle. They said was GHJ. We had an arc mark at H, and then we had GH with a hash mark. So now, because there's no K on the picture, I can just put the hash mark right there. Then my green triangle was GIK. Now your redraw doesn't have to be perfect. Clearly mine is not. I had an arc mark at I and a hash mark now at GI. So we're looking for something to help us prove these triangles congruent, because so far we have a side and we have an angle in each triangle. So side and angle is not enough to prove, because remember we need 3 parts. So let's look for something more. Is there a pair of vertical angles in here, in the separated triangles, that would help us prove the triangle's congruent? Or is there a shared angle or a shared side? Pause the video, take a minute to think about it, and then hit play when you're ready to discuss it. Well, me discuss it with you. So here, I know that in the original picture there's an X, and so I could find some vertical angles, but those are not going to help me in the huge triangles that we care about. So if I look at my redrawn triangles, which is super important, I notice that I have a G here and a G here. And if I look back at my original picture, both of the triangles have G as an entire angle in each triangle. So it looks as though we could mark this with 2 arcs, and because it's the same as itself in both triangles, we say angle G is congruent to angle G. And that's because of the reflexive property. And then if I mark up my S's and A's, I've already got an A, I have an S, and now I have another A. So 2 pairs of A's and an S. So that means we could have AAS or ASA, so we got to decide once again. Step 3, to prove those triangles congruent. Is my side touching just one angle, or is it touching both angles? Well, my side touches angle H with a hash mark, and my side touches angle G with a double arc mark. So it's going to be ASA, where the side touches both angles. So triangle GHJ is congruent to triangle GIK because of ASA. Again, you can think of this divider line for this T-chart as a because, right? You say the thing on the left because of the thing on the right. Your reason backs up your statement. All right, I know this was kind of lengthy, but hopefully you recognize that vertical angles and reflexive property can be used whenever you can find them in the diagram after marking up everything on your picture and making check marks to show that you've done it. All right, happy proofing.